So good morning, good afternoon, depending on where you happen to be. My name is Jeramiah Dooley, and we've got a pretty fun exercise in content sharing here for you today. By way of introductions, my name is Jeramiah Dooley. I'm one of the field architects here at SolidFire. I've been with SolidFire a little bit over a year, and my primary responsibility has to do with SolidFire reference architectures and points of integration with VMware, OpenStack, and CloudStack. Some of my contact information is there on the screen, so of course if you have any questions or if there's anything you want to follow up on, you can. And as with most good teams, I certainly don't do any of this alone. And for those of you who are active in the community, some of these names that are here on the Solutions Architects page are going to be pretty familiar to you. Our job is to provide as much coverage as we can across as many solutions as our customers are interested in. And this is an amazing group of teammates that help me put together the content that we're going to talk about today and help us drive those solutions and the ways that we can leverage the storage out into the field. We're going to keep this pretty casual, so we're going to try to make this fun. We're going to try to have a little bit of humor along the way. And from a SolidFire perspective, the tech solutions team, absolutely best job I ever had. Great group of guys, great tech to work with. Please feel free to reach out to any of us at any time, and if there's anything we can help with, or if there's anything that you want to follow up with. So a little bit of housekeeping before we get started. The presentation is designed to be as social friendly as it can be. Feel free to provide comments or feedback on your social media platform of choice. If you're on Twitter, please feel free to follow me and send any inquiries, comments, bad jokes, anything that you'd like to over. If you use that Fueled by SolidFire hashtag, it makes it easy for all of the Tech Solutions team to be able to jump in and help out. We will make copies of the slides available later on SlideShare. We will also, you'll get an email follow-up with a link to the video so that you'll be able to see the webinar as it happened. And please ask any questions that you want to through the chat feature down in the bottom left-hand corner like was mentioned earlier, and we'll go through them at the end with any of the time that we have left over. So what are we going to talk about today? There's really three topics that we're going to look at. The first is going to be kind of a state of the storage stack from an enterprise perspective, where we are, what the challenges are, what is it that we're trying to overcome, and then we're going to look at the 4 states of change, the 4 states of transformation. Particularly with workload consolidation, those are pretty standard when we talk to customers about this. The first is, what do you mean by workload consolidation? And then the second is that moment of panic where you realize that every storage vendor you've ever had has told you that what we're recommending here is not only not possible, but is not advisable. And then we'll talk a little bit about why it's okay to embrace that, and it's okay to look at what we're doing and see the value in it and all of the pieces that we're using to bring that together. We'll talk a little bit about how to get started, and then at the end we'll step through a year in the life of a data center. How is it that we see customers transforming from a legacy workload and app supporting platform environment into the SDDC, and what is the part that SolidFire plays in that? So again, we're going to keep it pretty casual, but hope to have a little bit of fun with this as we go forward. The first question that we get from enterprises is, why does everybody hate storage? As we look across all of the customers that we have, as we look across, in my background, I spent 4.5 years, right at 4 years, with VCE, the joint venture between VMware, Cisco, and EMC, and the storage was always the boat anchor. The storage was always the part that was the least flexible. It solved the least number of problems in the least efficient way possible. And so this idea that the storage is slowing down that adoption towards something like the SDDC that is more flexible, that's more adaptable, that is more efficient, really holds true in almost every enterprise that we saw. Right? So what we end up with is an inflexible storage platform that once it's on the floor, there's not a whole lot that we can do with it to adjust to changes in workload or changes in physical environment or changes in performance requirements. We waste an awful lot of time and money on the operation and on how it is that we provision the available capacity within them. Right? Being able to apply RAID overhead and disk groups, and how wide are you striping things, and how efficient is that, and what's the overhead for all of those things. It tends to be relatively ineffective, particularly over time, that storage arrays we put on the floor end up not necessarily performing as well 2 years in as they did on year one, both because of an inability to keep up with the technology, but also an inability to keep up with the change in what workloads are demanding. And ultimately, that ends up being unsustainable. We end up with lots of piles of storage all over the place. We end up with lots of different orchestration and administration headaches trying to enforce a consistent provisioning policy or a consistent management policy across all of them. And as a group, we can't, as an industry, we can't sustain that. So the question becomes, how did we let this happen? And I say we because I think that the enterprises in general have not been as demanding as they could have been from all of their incumbent and legacy storage providers. And the biggest thing that we overcome, not just as a company, as SolidFire, but as an industry around storage, is inertia, right? It is the phrase that I hate the most. There's a quick video that we're going to show here that kind of walks through what the core root of the problem is, I think, that's affecting storage directly. So for those of you who are connected to the webinar, you will see both the video and hear the audio. For those of you who are on the who are just dialed into the call, you're going to hear the audio only. So this is a pretty short video, but I think it's a good way to tee up the rest of the conversation.
Serious. Do you have any idea?
Thanks for coming in, guys.
All right.
All right.
Sit down.
Sit down.
You got
five apes in a cage.
You got a banana,
hanging by a string
in the middle of the cage.
You got some stairs
going to the
banana.
Pretty soon, one of those apes is going to go for the banana.
As soon as you hit the stairs,
you take a
hose
and you
spray all five apes with freezing cold water for 5 minutes.
Now,
some time passes.
And pretty soon
another one of the apes is going to make the same attempt, the same result. All five apes get sprayed with cold water. Now you turn off the cold water. You never use it again. One of the apes is going to go for the banana. He hits the stairs. The other four apes pounce on him and beat the shit out of him, right? Okay, understandable. Now you replace one of those original apes with a new ape. After a while, that new ape, he's going to spy that banana, and when he goes for the stairs, the other four apes are going to jump on him and beat the shit out of him, right? Now, time passes. You replace another one of the original apes with a new ape. That new ape is going to go for the banana. The other four apes beat the shit out of him, right? Including the first new ape, who has no idea why he's so enthusiastically beating the shit out of this poor guy, nor why he himself had the shit beat out of him, okay? Now you keep replacing these original apes with new apes until finally you've got a cage filled with five apes who have never had the freezing cold water sprayed on them, and nevertheless, not one of the apes will ever attempt to climb those stairs again. Why not? Because that's the way it's always been done around here. Thanks for coming in, guys. Those are for you.
So, that phrase, the phrase, that's the way it's always been done around here, we hear it a lot, particularly around storage, because there's such a legacy there. There's such a there's such a history of these are the technologies we used, and these are how we put them together, and these are the architectures that we're comfortable with. And so when we ask customers things like, why do you buy individual storage arrays in order to be able to support different workloads, we get the shrug of, well, that's just the way you do it, right? That's the way storage happens. That's the way enterprise IT is run. And some of that is just our individual biases. Some of that is the our upbringing and the things that we're comfortable with and wanting to stay in our comfort zone and wanting to be risk averse, right? That there's nothing wrong with wanting to be risk averse, but when you're risk averse to the exclusion of being able to solve the problems that you need to solve, the challenge, that's where the challenge really picks up. Some of this, though, isn't us, right? So some of this isn't the people who are consuming storage or using storage. Some of this is the changes that are just happening generally inside the industry. So if we look at what typically has been the storage environment, it all revolved around the best-of-breed appliances. Right? This is where SolidFire brought our first product to market. But if we look at any flash array vendor today, there's a combination of software and hardware that get delivered together in an appliance model in order for customers to be able to take advantage of. Right? What those look like, how those scale, lots of differences between even just the 4 companies that are on the slide now, but the fundamental model of here's an appliance, I'm going to put it on the floor, I'm going to rack it in a server, I'm going to power it from a UPS-backed data center, all of these things have generally remained the same. But if we look over the last 5 years or so, there's been some pretty significant changes, the first of which is that there's a significant number of enterprises who don't want to buy infrastructure at all. They want to be able to consume these things as services. They want to be able to consume the products and technologies that they want being provided to them by someone else, right? If they're not capable of going that far with it, maybe they want that storage delivered to them as part of a converged infrastructure. They want to have the non-recurring engineering taken out. They want to be able to stand something up quickly with as little risk as possible, with as much interoperability testing done for them so that they can get from the need of capacity to having inventory on the floor that they can start using as fast as possible. We also see the logical extension of that, which is the hyperconverged platforms. These being platforms that are going to include not just storage, but compute and the hypervisor as well, all in a single deployable block, a single deployable brick. And then finally, at the larger end of the scale, we see customers who want to deploy their software technology or their storage technology as software on commodity hardware. So some of the risk-averse nature of what we're seeing in the industry today is just due to the fact that these changes are happening really quickly. Right? There was a point in time 3 years ago where converged infrastructure was the biggest thing in the world, and now everybody wants to talk about hyperconverged. And we hear more from some of the platform 3 people around how software and commodity hardware is the only way to go. And enterprises don't know which of these paths to run down, and they certainly don't know how to get a consistent product across all of these paths. So we tend to go back to what we're comfortable with, and that's the traditional storage consumption models that we've used in the past. So if we look at this continuum, with the as a service on the left-hand side, the software as commodity hardware on the right-hand side, what we start to notice is that based on what is important to our customers, there are different places on this continuum that they're going to live. And if we look at things that customers care about, like ease of implementation, degree of vendor lock-in, flexibility as to how it gets implemented, which type of hardware are we going to use, best-of-breed components, those sorts of things, or cost efficiency, we can see that all of these models may make sense at different points in time for different customers. If you need the easiest possible implementation process, right, nothing's going to beat a cloud service provider. Go in, have them build it up for you, you use it, when you're done with it, tear it down. Nothing is going to be more easier than that from an implementation standpoint, but at large scale, software and commodity hardware is going to be vastly more efficient from a cost standpoint. And as we break this down with the different types of customers we talk to, the SMBs skew towards as a service and are moving that way more rapidly. The large enterprises are tending to polarize between the best-of-breed appliances and the converged/hyperconverged environments. And then the service providers have always been at the best of breed and greater, and tend to move more quickly towards the software and commodity hardware, simply because the implementation flexibility and cost efficiency tend to be very key drivers in those large cloud scale enterprises and in service providers that are offering services out to customers. Our job as a storage software provider is to be able to match as closely as we can all of the consumption models that our customers are using, whether that's as a service through any of the fueled by SolidFire service providers, whether that's as a converged infrastructure through our series of agile infrastructure reference designs, whether that's as the traditional best of breed appliance, or whether that is as software on commodity hardware through Element X. Our job is to take a consistent set of features and a consistent storage platform and deliver it out to customers in whichever of these methodologies, whichever of these consumption models make the most sense. So if we look at it through that lens, then the question becomes, what is SolidFire doing? What are the building blocks that we're going to provide in order that we can really start talking about workload consolidation? At its core, SolidFire is an all-flash storage array. The key difference between a SolidFire storage array and almost any other storage array on the planet is really twofold. First is how we scale, and then second is how we provision out of that scale and protect the workloads that are in there. And I think it's important that we try to tee up where the SolidFire product is looking to play, because as we're starting to talk about consolidating workloads, where those workloads are on the continuum of the I/O requirements and the capacity requirements inside the data center are pretty key. And if we look at that from side to side, right on the left-hand side, we've got the cheap and deep. This is going to be object storage, file storage, backups, archive, all of the things that we tend not to need to be very active after it is that we've written them out to disk. On the right, we have the performance at any cost group. These are typically transactional processing workloads and particularly trading platforms where microseconds of latency can be the difference in how a company performs or how revenue gets generated. In the middle, we have the performance and capacity. This is our private cloud sector. This is where we see most of our virtualization workloads run. And that part in the middle is the hardest because those requirements are constantly changing. We get new workloads all the time. We get updates to workload that change what the I/O patterns are. This is where, from an enterprise standpoint, we see customers consuming most of their time, most of the aggravation, most of the capital that they're investing into the storage platform is going into meeting the needs of that middle section. When all flash came on the scene, it tended to skew far to the right, mostly because of economics. So in version 1, where we had flash that was attached to PCI cards, we were trying to find the 1%ers, right? The most performance needing, the most latency sensitive applications we possibly could. When we moved to all flash arrays in version 2, we were able to push that down a little bit, but we were still providing one-off solutions. It wasn't a storage platform, it was a storage solution for a specific workload. From a SolidFire standpoint, we want to be able to serve all of it. Any of the requirements that you have for workloads, from that cheap and deep section all the way out into the high availability, high performance, low latency things that a normal all-flash array would be positioned for, we want to be able to support all of these workloads and not just support them individually, but support them collectively. So when we look at the actual consolidating workloads part, what you've got on the screen is what, particularly our large enterprises, we see them all over the place with the workloads. On the cloud orchestration, they may have some combination or multiples of OpenStack, CloudStack, and VMware. They've got virtualized infrastructure to support. They've got database after database that are all over the place being able to look at it. And then virtual desktops, right? Whether that be VMware, whether that be Citrix. All of these workloads have different I/O requirements. All of these workloads have different scalability requirements. All of these workloads may be deployed by different groups at different times for different reasons. And so the question that we ask customers is, what if you could run all of those workloads on a single storage infrastructure? And if you think back to that agenda slide, this is the point where people start screaming, right? This is the point where We have customers tell us, absolutely not. I'm a, fill in the blank. I'm a NetApp customer, I'm an EMC customer, I'm a Hitachi customer, an IBM customer, and I've been explicitly told that I will never put an Oracle database that requires transactional processing next to a VDI implementation on the same storage array, because you're just asking for trouble when something happens that you're not planning for, right? So what we're going to talk about from here on out are the ways that SolidFire is trying to solve that problem, and then what that looks like inside your data center today. From our standpoint, a storage array, our storage array, needs to have 5 things that we do better than anybody else on the planet, right? So each of these things, scale out infrastructure, self-healing, high availability, quality of service, automation, and inline reduction, are critically important to making an all-flash storage array be a part of a platform that can support all of the workloads. What we're going to focus on today are 3 of these. We're going to focus on the scale-out agility, we're going to focus on the self-healing, and we're going to focus on the guaranteed quality of service. Not that the other 2 aren't important in this, right? The inline data reduction certainly helps with the cost. The system automation certainly makes it easier to manage up the stack from the virtualization platform, particularly the integration in with VMware. But we're going to focus on the 3 of them that really are the nuts and bolts of why it is that we're going to be able to consolidate these workloads down. And the Lego pieces that we're going to be using to do this, and the thing that allows this to scale out and provide the pool of resources that we're going to talk about, are these 4 platform building blocks. These are the 4 models of SolidFire storage arrays. And I know that we're all fans of VMware. I've been a vExpert for 4 or 5 years now. VMware is not necessarily the best at product naming, so we've tried to simplify this down as much as we can, and we can kind of step through the logic of the product naming here. The 2405 is 240 gig drives. The 4805 is 480 gig drives. The 9605 is 960 gig drives, and the 9010 is 900 gig drives. So pretty easy to wrap your head around from what that looks like. Each node has an effective capacity and has a guaranteed amount of IOPS that comes with it. From a SolidFire perspective, 4 of these are required to create a cluster, and then you can scale them out as you go. And you don't have to scale them out in similar sizes or in similar quantities. You can, one at a time, pick whichever makes the most sense from a ratio of capacity to performance, and you can slide them in. And what that looks like is pretty straightforward. The idea here is we want to be able to provide linear scale. As you need performance or capacity, you add in what makes sense. We want to be able to expand or contract the clusters to be able to add that in as needed, and to do that completely non-disruptively. And what we most importantly want to do as we go through this process is never require a forklift upgrade again, ever. We never want you to buy a storage array knowing that in 3 years you're either going to have to replace it, or you're going to have to take a maintenance window to replace the controller heads. We never want you to have to wait 3 years in order to be able to use the newest version of whatever storage platform, storage node it is that we're putting out there. So the idea here is scale linearly, scale at your pace, 1 node at a time, as you need either capacity or performance, and we're going to guarantee that process for you. We're going to guarantee that every node we sell and every version of the Element OS software that we release is going to be compatible and interoperable, and anything that you have under a support contract is always going to work. We're never going to come to a point where we say to you, you have to upgrade a node in order to take advantage of the new software platform that we've put out. Everything that you buy and everything that you have under support will always be interoperable with the newest version of the software that we offer. The second thing here is that we're pretty much done as an industry talking about driveware on SSDs. And so in order to make that nice and easy for everybody, we just put a big guarantee on it. No restrictions on use case, no restrictions on workload. If we ever have a driveware issue with any drive, if we see that the driveware gets to a certain percentage, we're just going to replace the drive so long as the platform's under warranty. So we never want these to be obsolete. We want to be able to provide protection for the investment, and we never ever want to see another forklift upgrade. So we've used these nodes, we've created a cluster. we've given you this undifferentiated pool of capacity and I/O. And in most storage arrays, that pool of storage and of capacity and I/O get provisioned out to all of the disk groups and to all of the VMs that are sitting on the platform with no real guardrails between them, right? So we tend to over-provision. We tend to separate out physically in order to be able to provide guardrails there. What SolidFire has done is we have put in place a technology that allows our customers to provision the capacity of the storage array completely separately and independently from the IOPS of the storage array. And if you think about it, especially from the VMware environment, this is how we do everything other than storage, right? For the last 7-8 years, most of us have been putting in place 1U appliances that included CPU and RAM. And we use VMware and the hypervisor to pool all of that CPU and RAM and be able to carve up and provide out a fraction of that pool to the VMs that are running, which allows us to be more efficient, which allows us to drive higher utilization. Right? We can put reservations in place for CPU and RAM resources that we always want to be available regardless of what the capacity of the rest of the cluster is. We've never demanded that we have the ability to do the same with the 2 resources that come in every storage array. What QoS allows us to do is that every time we provision a volume, we have to tell the array what the size of that volume is. And in the screenshot we've got on the screen there, this is a 2 terabyte volume. And we're going to specifically apply QoS settings saying, here's the minimum, here's the maximum, and here's the burst amount of IOPS that volume is ever going to be able to get. So I provision the capacity I need, I provision the performance that I need, and I provision those out of that larger pool that is the cluster. These aren't optional. You can't choose not to apply QoS. This is a fundamental part of how we provision it out. It would be the equivalent of provisioning a VM and saying, I want you to use all of the CPU and RAM in this host, and then continuing to provision VMs with all of the RAM and all the CPU in the host. Right? We're not going to build in conflict or the need for one VM to take resources from another VM out of the box. We're going to provision that capacity and I/O separately. And what does that give us the ability to do? Today, if I have a single storage array, a single pool of storage, and I throw everything on there at once, in this case, we've just got some example applications that are running down there at the bottom. If something happens in the middle of the day or in the middle of the night during backups or database checkpoints, my applications that are using all of the I/O are going to negatively impact the rest of the applications, whether they need it or not. And what we're trying to drive with the QoS is the ability to provide swim lanes that say these applications are always going to have this much IOPS available to them. These applications are going to be limited into a bucket where they can never use more IOPS than it is that I want them to have, particularly around VDI. And what that looks like from a practical standpoint, we've got up here on the screen. So on the right, you can see that we have a VDI boot storm. And the VDI boot storm in this case is driving just over 1.5 gigs of traffic. And you can see the I/O on the array and the performance utilization on the array go up. And if we look on the left, the database volume that is also in the same array as that VDI implementation only has a minimum IOPS of 100. So since we've only told it you're promised 100, when that boot storm hits, we can see, and let's use my fun little pointers here, we can see here that the I/O and the bandwidth for this volume that's running the database is going to go straight to the floor, right? It's going to get from the 20,000 IOPS that it was running originally down to the 100 IOPS that we've guaranteed it, right? So it's doing exactly what it is that we've said we can do, but since those QoS settings are dynamic, how do we fix the problem? Instead of having to provision more storage, what I'm going to do is I'm going to change the minimum IOPS to something that is more in line with what that database requires with the SLA that I'm providing to the business. And what we're going to see is that the boot storm over here still happens, right? The boot storm is still there. The boot storm is going to possibly take longer to resolve because we've taken away some of the IOPS that it was using to process the booting of those VMs early on. But what we can see over here on the left is that my bandwidth to my database and my I/O to my database is going to stay rock solid and consistent. So what I've done is I've taken two workloads that should never, in a legacy array, be put side by side without significant over provisioning, and I've dynamically allowed the two of them to live together and to be protected from one another. So the idea, what we want to do is take all of these applications that we looked at earlier, and I want to sit all of them on a single storage platform. I want to guarantee storage performance to every application. I want to combine every workload it is that requires I/O of any amount and needs that I/O protected in any way. I want to increase the application density and resource utilization, right, which is the exact argument that we all made to our CIOs and CTOs 7 years ago when we wanted to start buying VMware licenses. We want to respond faster and with greater agility than ever before. Right? These are the core tenets of virtualization that we've solved on the compute and memory side. I want to solve them in the exact same way through the exact same platform with the same method on the storage side. Right? And when we do that, I think that we really start to simplify the storage that we have to manage on the back end for the workloads that we're using. So if we scale out the capacity in I/O, what does that look like as we start to move workloads around? What we've got here is a cluster of 2405s, right? So these are 240 gig drives. This will be about 35 effective terabytes of capacity and 200,000 IOPS. We put it on the floor and we start moving workloads over. We take our Microsoft SQL Server, which maybe it's our biggest headache. Maybe we struggle to cohabitate the SQL database with any of the storage arrays that we have on the floor. We move the SQL Server over. We put some capacity and performance on the array. We're going to spread that across all of the nodes. Everything's great. So now let's start moving more workloads. We take an OpenStack environment, right? It's a test dev environment. We're playing around with it. We're trying to see which workloads it is that we can move off of our legacy environments over. We put more capacity and performance load on the system. Again, we're going to distribute that out. Let's throw VMware and Horizon over, right? So again, as we continue to add load to the system, we're going to balance that over the 2405s. We get to a point where we say we need to add more capacity, and what we realize is that we've got plenty of performance. The 50,000 IOPS per node is great, but we want slightly larger capacity drives to be able to handle some of the workloads we're going to move over next. So instead of the 2405s, the next two nodes we add are 4805s. Again, we're going to balance all of that across all of the nodes, so there's no manual balancing, there's no disk group management, there's no mapping of RAID volumes to LUNs. It's one big pool of storage that we're going to balance across all of those. And then at some point what we realize is the 2405s, we want to move them over into another cluster. We bought some more and we want to try to balance out across the two of them so we can go ahead and remove them. And when we pull those out, again, we're just going to rebalance over the rest of the nodes that are in the cluster. We've never touched any of the workloads. We've never impacted QoS. Like QoS has been in effect and working and providing guaranteed performance for every one of these workloads the entire time that we go through that process. And we are ensuring that all of those workloads get the I/O that they need, regardless of what the state of the infrastructure is or where that happens. The node-based architecture also helps with failure handling, with high availability. In our case, we use a technology called SolidFire Helix. We don't use any RAID at all across anywhere on the platform. What we're trying to drive is no single points of failure, no manual intervention in order to be able to start a disk rebuild or replace a drive inside a RAID array or relocate workloads because that RAID array is going to take 3 days to rebuild. Our job is to maintain QoS in every one of those settings, regardless of what the failure rate is, and then to provide non-disruptive hardware and software. So as you can see from the graphic, every block has been written to different disks on different nodes. So the SolidFire Helix is a mirrored protection strategy where we're going to keep track of every block and we're going to lay them across different nodes in the cluster. If we were to lose a node, we don't have any data that needs to be rebuilt out of parity or be rebuilt out of some sort of striping environment. All we're going to do is reprotect the blocks that are still there and are still available to the excess to the extra capacity in the rest of the cluster. This gives us really incredibly fast rebuild times. When we have a drive that fails for whatever reason and we need to reprotect the data that was on that drive, regardless of the size of the cluster, regardless of how much data is on there, I mean, that's a 3 to 5 minute process, not a 3 to 5 hour process, right? And once that drive gets rebuilt, in the meantime, all you've lost is the capacity and performance of that single drive. There's no impact to my data path. There's no impact to the overall health of the cluster. We just removed that, that piece of inventory and reprotected the data around it. So the same way that we restripe or reprotect and rebalance everything when we add a node, the exact same thing happens when we lose a drive or when we lose a node in the cluster. And all of that's great and made better by how deep we're integrating it into the VMware ecosystem. Our job is to make SolidFire be the best block storage platform on the planet for customers who are choosing to run their infrastructure operations through a VMware platform. And we do that at its core by being who we are in the five features of the storage array, the 5 pillars that we're going to be as good at as we can. But we're going to do that through vSphere storage API support, right? We're going to do that through integrating QoS today with SIOC. We're going to do that through the VAI primitives. We're going to do that through the VASA providers today and the VASA provider from a vVol perspective. We're going to do that through integrations with SRM. We're going to do that through integrations with vRealize automation. All of these things that you're using as the telemetry and management tools to operate your data center, we're going to make sure that SolidFire sits in them as natively and transparently as we possibly can. And the goal there is we want to be the best storage for end user computing. We want to be the best storage for that private cloud automation. And in turn, we want to provide the best availability and performance that we can to the tier 1 apps that sit on top of it. And we want to make that as easy as possible to consume, right? So the feature set is all inclusive. There are no individually licensed features. Replication, integrated backup and restore, encryption, all of the things that you would expect out of an enterprise platform, all of them integrated directly into the tools that you're using inside the data center, all of them using the back-end block transport that you've invested in or that you're interested in moving to. That's how we're trying to solve that problem. And my hope is, at this point, that you started the presentation curious about how is workload consolidation possible, but hopefully at this point we've got your attention a little bit. Right? Hopefully at this point you see the pieces that we're putting in place in order to be able to really start to drive some simplicity and some consolidation into that data center. So what does that look like? This was a demo. We actually have a live demo of this where we run workloads on a 6-node SolidFire platform, and we beat them up and we do boot storms and we show million transaction per minute SQL databases not being touched. So certainly there's a lot of great follow-up that we can do out of here for those of you who want to see the actual deployment methodology for how it is that we put this in practice. But this is where we see most customers today, right? It's a legacy data center. We see lots of dual pathing from a networking standpoint, whether that's 1 gig and fiber channel. We've seen, particularly on the Cisco side, lots of FCOE in place. We've got a traditional compute where they take up lots of space, they take up lots of power. We're maybe not driving as much utilization out of them as we can because of the space constraints, and we've got lots of storage on the floor. We've got storage that's dedicated to applications. We've got storage from different vendors that's designed to provide different tiers of performance. And then we are manually balancing which workloads go where based on the characteristics of that storage that's underneath it. So when we talk customers through what do I want your data center to look like in the next year, we start with the evolution beginning. And in our case, that's a pair of top-of-rack switches and a 4-node cluster, right? So the beginnings of where this can go. And our first recommendation to customers is, I want to be the way you fix the problem that the applications you're having the most problems with. I want to be able to get a big win early on. Maybe that's with a VMware environment that you're trying to scale out. Maybe that's with a VDI project that you're trying to deploy. Maybe that's with a database that you're just having a hard time maintaining the SLA that you've committed out to the business. Whatever that is, I don't want to touch anything else in the data center. Just move it over so that we can start integrating into the platform and we can start looking at what sort of performance and capabilities we get out of the SolidFire array. So in this case, we move the Horizon View environment over. Customers and users are happy with the latency and performance they're getting out of their desktops. Administrators are happy with blindingly fast recomposes. Not having to worry about a boot storm taking over all of the IOPS inside the environment. We've come to a point where we've shown the value of what we can do for a small number of apps that were causing a lot of headaches inside the data center. The inflection point is when I start consolidating workloads and using that as a driver to change the infrastructure that's in the data center. So in this case, we start to draw down the legacy switching, both on the fiber channel and the 1 gig side. We start to up-level the compute into something that we can drive a little bit harder. Now that we don't have to spread workloads out over multiple clusters, we can start consolidating things down into a smaller footprint. And we start moving to that same top-of-rack 10 gig model for the compute that we have now put in place for the SolidFire storage. We span out the SolidFire array. We non-disruptively double the amount of capacity that's in the array. We start moving more of the workloads. We start moving the Microsoft core applications on the back end. We start moving some of the databases. The things that we were tiering across multiple storage arrays, we start to use QoS to drive down the complexity of that. Phase 1 of the next generation data center, right? Phase 1 of the blueprint that VMware has around software-defined data center is when we are fully committed to a model where I'm going to virtualize all of my resources into pools. I'm going to virtualize all of my I/O and capacity from a storage standpoint. I'm going to virtualize all of my CPU and RAM from a compute standpoint. And we're going to start to make those look pretty homogeneous in how they roll up into the virtualization platform and how it is that I deploy them out. Right there, at least for a short time, there's still legacy SAN that can be used for cheap and deep applications. There's siloed appliance storage that may be, or application storage that may be used for workloads, Oracle workloads that still need to be upgraded or still need to be put into a place where they can be virtualized. But over time, that excess storage goes away. Right? We've consolidated to a single platform. We're using QoS and the scalable nature of the node-based architecture to its fullest advantage, the same way we've been doing that with VMware on the compute side for the last 7 years. And now we start to have some fun with it. Right? Now, once we've got this consolidated data center plan in place, now we start being able to figure out what is it that I can do from a multi-data center standpoint. Right? The most basic of those being an A/B topology where replication, and SolidFire supports all 3 modes of replication that customers would want, that being snap and copy, asynchronous and synchronous, in whatever directions we need to between as many volumes as we want from site A to site B, whether that's direct storage or whether that's integrated through SRM. Now we have an easy way to extend that storage platform out across multiple data centers. What we also get is the ability to start integrating directly in with cloud services. For customers who have AWS environments that they need to integrate in, or for customers who want to start using cloud services, and particularly object storage services, as a way to back up data or back up volumes, being able to use SolidFire's direct integrated backup platform to take a volume and copy it out to any Swift or S3 capable cloud storage platform becomes the way that they can get data off-site, right? It becomes the archive tier. It becomes the way that we take data and protect it and move it into a platform that isn't in the data center or that isn't necessarily inside the infrastructure that we're trying to back up. And then those just become cookie cutters, how many sites do you need? Where do those sites need to be? What's the replication relationship between those sites? Those become business questions, not technology questions. We've got customers who are happy in a single site. We've got customers with dozens and dozens of sites around the world, and the need to set up very granular relationships between the workloads in those sites, the VMware platform that's running them. At this point in the evolution of that data center, those become completely business-driven decisions. We don't have to tell the business, no, you can't do that anymore. And then the last element for the largest of our customers, or for the customers who are driving towards a completely homogeneous pool of resources, is the idea of Element X. And from an Element X standpoint, we don't care about the hardware. The software is the magic. The software is what we do. The hardware is what it runs on. And so being able to support the software on validated instances of hardware that are being driven into these cloud scale and service provider environments means that there is physically no difference between a compute node or a storage node. The only thing that matters is the software overlay you put on top of it. So in this case, we've got 8 racks of gear, different vendors, maybe different data centers, but I choose to turn some of those into compute and memory resources by overlaying them with VMware. I choose to turn some of those into storage overlays or storage resources by overlaying them with Element OS through the Element X program. So we've gone from multiple silos, non-contiguous network topologies, low density, kind of management nightmare across multiple levels of the infrastructure into something where the software is the magic, and the software deployed on the node determines the personality of the node. And when we're here, that vision of the next generation data center is really complete. So the closing thoughts, if you think back to the video, don't be the apes, right? I mean, we know that from a storage vendor standpoint, we've all been getting the hose for the last 10 years, right? But the bananas up there, they belong to you, they belong to us. And the more that we can help each other is part of the community, and the more that we can help each other as part of the industry, I think we have the right, we've certainly paid the dues to look at our storage providers and say, I don't want to do that anymore. I don't want to buy 5 different storage arrays in order to be able to support the workloads that are important to me, because consolidation at a certain point, you virtualized what you can virtualize. Consolidating those workloads down and simplifying the infrastructure is going to be the only way to increase that efficiency to any significant degree, right? It is what's left on the table for us to be able to drive some of that cost and complication out of the platform. And then the architecture matters. What we do is largely tied to the architecture that we chose. The shared nothing node-based architecture really is the driver for so much of our ability to scale, our ability to provide data protection and high availability, our ability to provide QoS. Ironically, the flash is not the secret, right? Flash is great. Flash is fast. We all know the benefits of flash over spinning disk. But in our case, what flash gives us is consistency, because if we get a consistent response time, if we get consistent latency out of the disk, then all of the data services that we put on top of it become that much easier to guarantee to the end user. So in our case, the architecture is really what matters there. The media that we write that to is flash, because that's that's the fastest and most consistent we can get today. But as we go forward and as new storage technologies come out, plugging those in underneath Element OS will be a trivial exercise. The goal is always to be able to be as consistent as possible so that we can offer that level of reliability and that level of protection out to our customers. So I hope this has helped. I hope that we've talked a little bit around kind of what the challenges are and where the issues are today from an industry perspective. We went into a little bit of the SolidFire building blocks and how those building blocks translate into the features that we use to justify and validate pushing down consolidation across all of the apps that are inside the data center. And then I hope that it was helpful to see how that transformation happens inside the data center and how the infrastructure that supports the workloads changes as the platform that is supporting those workloads changes. Thank you all for the time. We hope to see you again on the next webinar. that we put together, and I really appreciate everyone taking time out of their day to talk to us.